All right, in this video, we're going to be looking at this problem right here. So we have how many moles are in 3.16 liters of helium at STP. Now, one of the things that I want to point out is the phrasing of STP. And we've learned about this before, and we've learned about this in particular when we've talked about our gases. And we want to remind ourselves that STP stands for standard temperature and pressure. And the reason why this is important is because whenever you see a problem like this, and it talks about being at STP, you want to remind yourself of our conversion factor. And that conversion factor that we know states that 1 mole of any gas at STP will have a volume of 22.4 liters. So this is a known, and this is really important. And as you see, this conversion factor right here is going to be able to convert us between moles and liters and then back and forth. So this will get us from liters into moles or moles into liters if the gas is at STP, which in this problem it is. So let's go ahead and set up our problem. You always want to make sure that you're starting off with what's given in the problem. So we know that we have 3.16 liters of helium. And I'm going to create my dimensional analysis problem. I'm going to make sure that when I plug this in, I put my 22.4 liters on the bottom because these units need to cancel out, and then I have my 1 mole on top. So my liters cancel out, and if I were to plug this into my calculator and type in 3.16 and divide it by 22.4, I will get 0.141 moles, and this is of helium gas. So it's a pretty straightforward problem. Again, the big thing is recognizing that at STP, this is true because that's going to save you a lot of work. Now what we're going to be looking at is, what about a problem that isn't at STP? How would you go about solving this same type of problem? Okay, so we have this problem that's actually very similar to the last one. And it says how many moles are in 3.16 liters of helium at 27 degrees Celsius and 0.750 atmospheres. Now, if we look at this, we're given still 3.16 liters of helium, and we're still asking how many moles. The big difference with this problem is that it's not at STP, and that's going to create a big difference, especially when it comes to our calculations. So in order to solve for this one and figuring out how many moles, we're actually going to have to use our equation PV equals nRT. So the first thing I'm going to do is I'm going to identify all of our variables. So let's identify what we are given in this problem. We know that our volume is 3.16 liters. We know that our temperature is 27 degrees Celsius. However, we cannot keep this in Celsius, so we're going to convert it into kelvins by adding 273. So now my new temperature is 300 kelvins. We have to have, when we use this equation, our temperature in kelvins. And then we have, of course, our pressure, which is 0.750 atmospheres. So let's go ahead and take a look at our equation. Our equation that we have is PV equals nRT. Our unknown right here is our moles. We also want to remember that R is our gas constant. And that has a very specific value, and it's 0.0821, and that's atmospheres times liters over moles times a Kelvin. So we'll be plugging that in. So let's go ahead and start isolating our variables. So I'm going to go ahead and I want to get n by itself because that's what I'm trying to solve for. So I'm going to divide both sides by r and t to isolate n. And my new equation ends up being PV over RT equals n. So let's go ahead. We have all of our variables. We have them within the right units. So let's go ahead and just plug that into our equation. So we have our pressure, which is 0.750 atmospheres. We're going to multiply that by our volume, which is 3.16 liters. We're going to divide that by R, our gas constant, so 0.0821 atmospheres times a liter divided by moles times a Kelvin. Notice that I did put all my units on this constant because you will see that they cancel out. So it is important to actually label all of your units. And then we have 300 kelvins. Our liters cancel out, our atmospheres cancel out, our kelvins cancel out. So we are left with the units of moles, which is what we wanted because we are trying to find the units of moles. One thing that I do want to point out is that when we add this together right here, all these zeros are actually significant. So when we write out our final answer, our number should have 3 significant figures. So if I plug that into my calculator, I get my number of moles is 0.9, whoops, forgot a zero, is 0.0962 moles of helium. Now, if we compare that to our previous problem, we saw that our previous problem, so in the previous problem, our amount of moles was actually different. It was 0.141 moles, and that was at STP. So notice that there is a significant difference between these two values when we're talking about something at STP and we're talking about something that is not at STP. The big thing is that our pressure is lower, which means that there's going to be fewer moles of gas within whatever it's in, a balloon or a rigid container, that there are fewer moles of gas, which are going to exert fewer amounts of pressure. Because remember, pressure is how many times those molecules hit the sides of the container. So if my pressure is lower, that means that I have fewer collisions, which means that I have fewer moles of gas.